Hello friends, welcome back to my YouTube channel MS Maths. In this video, we are going to discuss about the equation of motion of fluid, and it is basically the Euler's equation. Before watching this video, you should have an idea about that what is the Pascal's law for like basically the fluid. Still the fluid it is in rest position. It means we have discussed in our previous videos that what is the Pascal law. Pascal law says that the intensity of pressure at point in a fluid at rest is at rest is same in all directions. Okay, so basically the at rest, in the rest situation of the any fluid, the intensity of the pressure at the point or at the point of the fluid is same. Okay, so the intensity of pressure is same in all direction for the rest of the fluid. Now in this case we will find the equation of motion. Okay, so we have already discussed that the part of that pressure of the surface or like net pressure in a fluid element. So that concept we'll use in this video. So now let's start this topic that let P be the pressure and rho be the density at point P x y z. Basically we have considered the fluid particle, which is like rectangular. You can see here in the diagram that this is the x direction, y direction, and z direction, and the name is basically in this in such a way that A, B, C, D, E, F, G, and P is the midpoint of this. Now the length at which the P is present, that is basically del x, del y, del z. Like basically the length of the element is basically del x, del y, del z, and length at the P from the length from origin to P is basically del x by del 2, del z by 2, and del y by 2. Okay, so the P is the pressure and rho be the density at this particular point, or basically the midpoint of the fluid element. In a in viscous fluid, this is in viscous mean that viscosity is 0. For this, it means we have considered the ideal fluid here. Consider an elementary rectangular rectangular paraloid with edges of the length del x, del y, del z parallel to the coordinate axis, having P at its center. Okay, this is capital P basically. This is basically the capital P. We are talking about at this point is like this. The P is a point, not pressure. Having P and its center is like P is the center. Let U, V, W are the velocity component in the direction of x, y, z, and Fx, Fy, Fz be the component of external forces per unit mass at point P. Now, the force on the plane through the point P, basically it is a parallel to the, if we are talking about a particular surface, so that is parallel to that particular that surface or that axis basically. So the forces, I'm writing the forces on the plane through the point P for the surface is basically is parallel to the surface OBFC. You can see it. This is OBFC. It means we are talking about this phase. So the force on the plane through the point P, it means we are talking about this force. The force acting from point P. It is nothing but we have already calculated in our previous video, that is basically the pressure at point P minus dou P by dou x. Minus is because of that it is in minus x direction. And the length from origin to this point is basically del x by 2. So it will be del x by 2 into, this is the force. Basically we are talking about the force. So we know that what is the pressure? It is the force per unit area. So what is force? It is nothing but pressure into area. This is the net pressure, okay, minus into area. The area of this surface is basically del y del z. So it will be del y into del z. This will be the area of this rectangular surface. Now on the other hand, we calculate the net force. Net force in x direction due to forces on OBFC. So basically OBFC, this is the surface, and due to this surface the net force, this surface and the opposite of this surface is ADEG, I think ADEG, and this surface and the surface ADEG, okay, is, so what is the net surface for this is basically minus dou P by dou X, del X, del Y, del Z. How is it? Basically in this case we'll consider this is in the particular this like for this surface, and similarly for the surface ADEG it will be P plus dou P by dou X and del X by 2 into the area of this surface is basically it is in the plane, like basically this is del Y and this is nothing but del Z. So it will be del Y into del Z. Now we will find the net, it means this minus this, okay, then we get this thing. Now next, the mass of element, the mass of fluid element is basically by the density, so that is density into volume, it is the volume, because where V is volume, it is nothing but del X, del Y, del Z. Hence the external forces on the element on the X direction. So the all external forces is basically, we know that the local total acceleration, because we are finding the force, the relation between force and mass is one and only acceleration, or by the Newton's second law is basically, we know that du by dt is the total acceleration of element in x direction. So therefore by Newton's second law of motion, so by the Newton's second law of motion we'll have the equation, Newton's second law of motion, the equation of motion is basically F is equals to mass into acceleration. Now we have F. What is F? That is dou P by dou X, del X, del Y, del Z, plus the net force in the direction of X into the mass, that is basically rho del X, del Y, del Z is equals to the mass. What is the mass? Rho del X, del Y, del Z into du by dt. So we can cancel these all the things, that will get rho, the net force in the direction of X, minus dou P by dou X is equals to rho du by dt. Now so it will be, we can write du by dt is equals to f of x minus, we can divide this rho in this way, that 1 upon rho is dou P by dou X. This is basically the equation of motion along X direction. Okay, so we can generalize it as d by dt is equals to dou by dou t. We know that this is the relation, and we can use this relation as q into v, where q is basically the velocity component, velocities, that is in the direction of x, y and z. Now we will have dou u by dou t plus u du by dx plus v du by dy plus w du by dx. What is this? Now we will replace this thing with this. Okay, so the meaning of this is nothing but du by dt. This is the relation that if I will apply u here, then u here. Okay, now next thing will be, so it will be, I think it is basically the du by dt, and it is the like divergence, sorry for that, it will be the divergence of these two. Okay, u and yeah, this is like divergent, not v, sorry for that. Okay, we'll have the right hand side is basically fx minus 1 by rho dou p by dou x, and then if we'll put v in this equation, we'll get dou v. It means this will be in the direction of t, dou v by dou t, plus u into dou v by dou x, plus v into dou v by dou y, plus w into dou v by dou x, oh sorry, not x, it is y, sorry for that, it is x, y, yeah, x, y, z, obviously it will be x, y and z, so here will also z. So it is basically net force in the along y direction minus 1 upon p dou p by dou y. If I will put w in this equation, I will get dou w by dou t plus u dou w by dou x plus v dou w by dou y plus w dou w by dou z, net force along z upon 1 upon p minus 1 upon p dou p by dou y. So these are the equations that we can consider that it is Euler's equation, and it is nothing but the equation of the motion of fluid. So basically it is in x direction, y direction and z direction, these all the equations. So thanks for watching my video. Keep watching MS Maths, and for more videos you can follow my YouTube channel for MSc Mathematics and higher mathematics. You can follow my YouTube channel where you can get the solution, numerical solution, and basically all the types of like topics which is related to the higher mathematics. So thank you, bye bye.